Okay, in this problem we have a circular conducting loop, and it's being rotated in a uniform magnetic field. And again, this is sort of a three-dimensional image projected onto a two-dimensional plane, so it can be a little bit tricky. At this particular instant in time, everything is in the xy plane, so it's kind of easy to see. But as time goes on, you can see the right edge here is going to actually come out of the page towards us, and the left edge of this loop is going to start going into the page. We're asked to say what the EMF is as a function of time. Here we just have a plot of it. And I think the best way to do this is actually looking at Faraday's law, where we see that the EMF is just equal to minus d phi dt. And so we can write an expression for the flux through this loop, and so I'm going to do minus d dt of the flux. Well, the flux is just going to be equal to the area of the loop dotted into the magnetic field. So I'll just write that as the magnetic field times, it's the dot product, the cosine of the angle between them. And exactly what that angle is, remember, it's the area vector. So in this case, the area vector is either pointing straight out or straight in. We can sort of define that. And so that'll be changing in time. So if I say at time t equals 0, it's pointing straight out. Then at any time, because it's rotating with angular velocity omega, I can rewrite that as omega t. Then if I take the derivative of this entire thing, the area and the magnetic field are not changing, so I just get A times B. This minus sign here we're going to check in just a second. But then when I take the derivative of cosine omega t, I get omega times the sine of omega t. So we want something that looks like a sine, and I get rid of A, B, and E. I have two choices here. I have D and C, which both could be good. So really the question is, does it start with a positive current, which is defined as clockwise here, or a negative current? And here I'm going to use Lenz's law, and it says that the induced current will oppose the change in flux. So we're starting with lots of flux pointing out, right? As I rotate, I'll have less flux pointing out, so I'll lose some of these. So I'm going to want to create a flux that's going out, and in order to do that, what I do is I want my fingers coming up through the loop, and so I put my thumb, if I put my thumb this way, my fingers will always come up through the loop the way I want them to. So I'm going to have a counterclockwise, which would mean that would be negative. So D is the correct answer there.